All right. Well, I would just like to thank everybody for joining us today for our discussion on implementing water circularity for communities and industries. So I'm Lucy Pugh. I lead AECOM's Global Industrial Water practice, and I've spent my entire career helping industries solve their water and wastewater treatment challenges. And I'd like to introduce my colleague, Dr. Vijay Sundaram. Vijay leads AECOM's global OneWater practice. And Vijay has 20 years of experience applying potable water reuse solutions all over the world. He has done extensive research in technology development and application of advanced treatment processes for both indirect and direct potable reuse. So every day in the United States and around the world, billions of gallons of water are extracted and treated for use by communities and industries. And the wastewater that's produced, again, billions of gallons, is treated to very high quality and discharged back to the environment. This graphic depicts the OneWater cycle and just illustrates that water, surface water, groundwater is extracted and treated for potable use. It's stored and distributed to communities, to industries, and for other uses. And then the wastewater that's produced by those industries and communities is discharged to water reclamation facilities where it is treated, again, to very high quality and discharged back to the environment. And what we'd like to talk about today is short-circuiting this water cycle a bit and using that wastewater or water reclamation facility effluent, extract greater value from that effluent and treat it for both potable reuse and for reuse as processed water for industries. So our agenda today, Vijay is going to talk a little bit about the drivers for potable reuse, the types of reuse and treatment trains that are used, and then also present a number of case studies. And then I'm going to talk about water reuse for industry, including the reuse of water reclamation facility effluent, and then also reuse of industrial wastewater effluent within the industry, and also a couple of case studies. And then Vijay is going to wrap us up by talking a little bit about the impediments, what's preventing the widespread implementation of reuse. So now I'm going to turn it over to Vijay to talk about potable reuse.
Good morning, everyone. Thank you, Lucy. This is one of those events I'm very passionate about, reuse, and this is one of those events where we are doing both communities and large-scale community-scale projects on reuse and the industrial scale, that industrial size and industrial scale projects that Lucy is going to talk about. And let's talk about the community scale reuse. I just want to start with the drivers, or why people are doing these type of reuse projects. And also within our practice, we think of OneWater is kind of the umbrella why, how we are planning for this. And also the reuse goes under that as a tool in the toolkit to implement those principles. And in terms of drivers, the first and foremost, I'll start from the left top quadrant, where the economic development and urbanization, similar to other growth-related discussions, when we look at growth, reuse provides very sustainable growth and provides sustainable water to support. And there is a lot of drivers that we see related to this. And then when I move to the top right quadrant in the top, it's a diversification, and it's starting from early 2000s, and now there's a lot of small and large communities getting impacted by not having very much diversification in their water portfolio, where if you have a groundwater, if it is dried up, that happened in East Porterville in California in the past, and this could happen in other small communities or large communities again. So having a local source, which is our treated wastewater effluent, municipal effluent that could be repurposed and refreshed for the future use, provides very much reliable, sustainable supply, which is locally sourced and drought proof. And the bottom left corner, we are talking about, this is an emerging trend that I've been watching for over 5 to 10 years now in the industry. there's a lot of stringent nitrogen, phosphorus removal requirements coming down to the wastewater treatment plant effluent discharge. And also PFAS is one of the new addition to that list. And with all these additions, what happens is there is a lot of money, billions of dollars getting spent in the wastewater compliance. And the thinking here is, if we are spending that much on those, can we reuse those water and keep it in the community, use it for other purposes? So we'll talk more on that today. And the last one on the bottom right quadrant, we are talking about climate adaptation. And we are seeing this a lot about flood and drought cycles. And let's say groundwater recharge projects could be a boon to these, addressing these and taking care of the flood and also storing water in the future. And also some of the groundwater recharge projects helps with, it has shown the evidence have been very powerful to show that groundwater recharge, large scale recharge, can address for land subsidence and also provide a rebounding effect and saltwater intrusion in the coastal areas. So you will see there's a diverse drivers, and every community has its own set of drivers, but this is a kind of an overall update we have on what we are seeing around the world. And we talked about the types of reuse. This is one of my favorite graphic when I worked as a chair for WEF in their water reuse roadmap about 5 years ago. And we developed this graphic called water reuse spectrum. The x-axis here is the important one. It talks about various types of reuse, and the y-axis could be for very many things. Here we are talking about how much monitoring, how much treatment intensity is needed based on these uses. And you will see some of my case studies today are all about potable reuse. That doesn't mean that you need to do that in every community. And that has been where the innovation and implementation is happening in the past 5-10 years. That's why I picked those. But you will see we could start from an environmental use to the agricultural reuse, industrial reuse, and potable reuse. And Lucy is going to touch on the industrial reuse. And there's a lot of successful case studies on agricultural reuse and wetland restoration. It looks like it can be achieved very easily. And it provides really good community asset. We have other case studies where the whole community was able to use these kind of projects to their quality of life benefits. I mentioned about potable reuse that is becoming a focus for our industry in the recent times. I will start with where in terms of types, even one more step into these things, connecting to the treatment a little bit and also the types of potable reuse. We all start with secondary biological effluent in this community scale reuse. And there are some decentralized one, for the interest of time, I couldn't be able to cover those today. But from the community scale, we all starting from municipal effluent. And then for non-potable reuse, we may do filtration, disinfection, use it for industries, cooling towers. Lucy will expand more with the case studies and other considerations. And we could go for medians, irrigate the golf course, which still offsets the potable water demand. So it's still, there is a place in the community for doing this. Then we'll shift to the right in the fork, where this is the potable reuse, requires advanced treatment, including membrane-based or carbon-based treatment. We'll talk about it in a minute. And within that, use this acronym, indirect potable reuse, IPR, direct potable reuse, DPR. And I use this graphic. It is coming from our assembly bill in California that explains this a little bit more, and it helps us to understand what these means to the public. And we use these in the public forum, where it's mainly all about where we are augmenting the drinking water supply. If we augment the groundwater after advanced treatment coming from the municipal treated effluent, that's a groundwater augmentation. If we are augmenting the large reservoir that feeds the drinking water plant, there is a reservoir augmentation. Those two we categorize at indirect potable reuse, because these groundwater or large reservoir provides a very good environmental buffer. The bottom two is of interest, and I work across the states in the west to east coast, and there is a lot of interest in doing these because it avoids the additional barrier requirement, finding a reservoir or finding a suitable groundwater basin that we can use. So raw water augmentation is where it still requires some kind of a tank or something to equalize as much as needed for blending, but you are feeding to the raw water system, raw water source water pipeline to your drinking water plant. That's the raw water augmentation. The last one is going directly to the distribution system. We call it treated drinking water augmentation. And this is project in Texas that are planning on in construction, and that will be having this type of method. I mentioned about treatment trains. The workhorse in our industry is the reverse osmosis based train that utilizes like a membrane filtration as a pre-filtration, like a low pressure membrane as ultrafilter, going to reverse osmosis, and having UV light and advanced oxidation with chlorine or peroxide to go after 1,4-dioxane and NDMA. So that's what you will see in Orange County, California to Singapore and other places. However, the one downside to that is, or one limitation to that is, it produces a reject stream that has all the CECs and salts in it that we need to manage. If you're inland, such as Reno or Denver, then it becomes a big issue of how to manage the reverse osmosis concentrate. So that's where carbon-based systems utilizing ozone biofiltration and granular activated carbon comes in very useful for those communities. And a lot of my personal research and doctoral work is on this carbon-based system, how we can prove that in terms of contaminant removal, it will not be able to touch the TDS salts and total dissolved solids, but it will be able to go after the pathogens and organics, bulk organics, and CEC, such as hormones and pharmaceuticals. The last one, we are having a hearing in California tomorrow on DPR. DPR rulemaking is happening right now. And one of the thoughts is to have ozone biofiltration in addition to reverse osmosis if there is an DPR projects in California. It's in the works. There's a lot of commenting period is happening right now. We will see where it goes through our rulemaking in our state. I'm going to shift gear to a couple of case studies. We saw the types and treatments that are used, and I'll start with Hampton Roads Sanitation District SWIFT program, which is the Sustainable Water Initiative for Tomorrow. And it is one of those game changer in the East Coast in the US, where it is using the carbon-based treatment to plan and recharge up to 100 MGD. And it's about, our program team is working with Hampton Roads SWIFT program team. And we are, it's up to over $2 billion project. And this is about 33 discrete projects. You'll see all these dots, various treatment plants getting, adding to for the tertiary filter, or what we call as a SWIFT train, which we are showing the ozone biofiltration based train, and some are getting decommissioned. So it's a large program with a very much of a goal to recharge in a large scale, because this area is seeing a land subsidence and other environmental issues. And as you can see, it's also very successful with getting low interest loans at very low interest rates with EPA on WIFIA program. And this is the same program. I just thought of this graphic is a lot more easier to see, where they are traditionally sending to the bay, and nutrient is a big issue. By doing this, they are also utilizing the investment for recharge and also protecting the bay. Multiple benefits coming out of this program. I'm shifting gear to all the way in the Southern California. This is the East County Advanced Water Purification, the Joint Power Authority project in East County, San Diego, Santee, California. And if you look at this project, this is a large sewer shed where they're diverting the raw wastewater, having a water reclamation facility with secondary treatment, an advanced treatment facility using reverse osmosis, and taking the purified water and augmenting their lake that they're already using for their water treatment and using as a raw water lake. So this is a very good reservoir augmentation project that helps the community tremendously. As you can see, this adds about 30% of this community's water supply in one single project. That's, I think, a key benefit of a large-scale community-based portable reuse projects. The impact is very significant. And in terms of treatment train, since we are diverting the raw wastewater, Our team has been working with this program as a design builder with our construction partner on 2 large packages that works on water reclamation plant, advanced treatment plant, and pipelines. And as you can see, our design team has been working on secondary system mainly suitable to create water that's needed for the potable reuse. And it utilizes high recovery reverse osmosis with 95% recovery. That's one of the first full-scale system to target this, and we are working to achieve this at 95% recovery using closed circuit reverse osmosis as a secondary reverse osmosis strength. This could be a knowledge that could be transferred to anywhere, that brine minimization, because that's the water that's not getting utilized. So it used to be at 80–85%, and this project is pushing the innovation to about 95%. And I want to touch on a groundwater recharge project in the West. That's a OneWater Nevada project in Reno, and it is led by a partnership between a water agency, Truckee Meadows Water Authority, and City of Reno has a wastewater treatment that's shown as a Reno State Reclamation Plant in the project map. And we are taking the UV treated effluent from that plant and go for advanced treatment with ozone biofiltration across the street. And then we have this blue pipeline for about 6 miles, and it goes for polishing with GAC and UV, and we do recharge with it. And this is an example of a project where it provides multiple benefits. It diverts water going to a lake that has, during the wet season, has a prone for flooding. And at the same time, we are keeping the golf courses and others using their non-potable. That's a one very good example where we are keeping non-potable and potable alive and ready to go. And that's where for other communities, these various reuses are not exclusive. You can do everything together, and it actually provides very good, reliable water portfolio diversification for a project. And it utilizes ozone biofiltration, and I spent several years of my career working with this team, developing the ozone biofiltration since about 2008. We've been working on this and have a lot of good success, including use of dissolved air flotation within the potable reuse train, as shown in the treatment train. Last one I want to touch on is our program team and our partners have just kicked off this, helping, MWD has been working, Metropolitan Water District of Southern California has been working on this project. It's a very iconic project, has been in the planning, testing mode for several years. Now our program team has started the program side of things, releasing all these projects coming up. So it's a very much of a large scale project as shown in these numbers. It's about 150 MGD of purified water getting recharged or augmented, and it's one of the largest programs in the world. And there is a lot more projects, a lot more activities that will be coming up from this program in the coming years. And you will see that when WEF circulates this slide deck, you will see we provided the web link for all these projects. They are very much of a thought leaders and iconic program developers in this industry. So we would like you to go and check that. It's often updated and for public outreach and other purposes. With that, I'll transfer over to Lucy.
Thank you, Vijay. Just trying to find my camera there. Those are some fascinating projects. Wow. So I'm going to spend just a couple of minutes talking about water reuse for industry, in both water reclamation facility reuse for industry, and then also reuse within the industry itself. So the drivers for industrial water reuse vary with the industry, but most companies have water stewardship goals that they need to meet by a certain date. And so a big driver is just meeting those goals, reducing the overall water footprint for an industry. Some industries are located in water scarce areas, and so it makes sense to reuse water to preserve the water resource. That also helps with resiliency to preserve the industry's operations into future years. And then a lot of industries are faced with very stringent effluent discharge requirements that are driving them to use technologies that are producing very high quality effluent. And so it makes more sense to just reuse that effluent rather than to discharge it. The water use among various industry sectors varies a lot as well, but these are some representative water uses for general industry. Water use for utilities, steam production and cooling water can represent a significant water use. And cooling water in particular doesn't necessarily require very high quality water. And so that's a good choice for a reuse project. Process water includes the water that might be included in the product that the industry is manufacturing, such as a beverage manufacturer, or it could be water that contacts the product, such as in metal machining or coating processes. And then most industries also use cleaning water. That can include equipment cleaning, floor washing, sanitation operations. So those are some general water uses among industries. A good place to start when looking at water reuse for an industry is the facility's water balance. Most industries already have a facility water balance. It's a good idea to update that water balance and then have a look at where the major water uses are. The water uses that require the most water and the lowest quality water might be good options for reuse. The water quality requirements vary a lot. As I mentioned, cooling water may not require high quality water, whereas processed water may require very high quality water. And then steam production, a lot of times the industry would have its own treatment system for production of boiler feed water. And so it's good to understand the constraints and the capabilities of those treatment systems and understanding the water quality that's required for those treatment systems. So reuse of a municipal water reclamation facility effluent could be a good option when the reclamation facility produces enough water to supply all or most of the industry's water needs. There's going to be an investment for pumping and conveyance of the water, so you want to make sure that you maximize the value of that investment by producing a good proportion of the industry's water needs. It's also helpful if the industry is located close to or nearby the water reclamation facility to minimize those pumping and conveyance costs. And then also a good match between the reclamation facility's effluent quality and the industry's requirements. Treatment can always be provided to make those quality requirements match up. And it's good to understand the reclamation facility's effluent characteristics beyond what's normally monitored for discharge. So you're going to want to know a complete ion balance, all of the anions, all of the cations, and other microconstituents that may not be monitored, but could impact the industry's water use. So speaking of those characteristics, some potential impacts of switching a water supply to a reclamation facility effluent can impact the reject and the waste streams from the processed water treatment that's used by the industry. So there may be, if there's an increase in total dissolved solids, for instance, there could be an increase in the reject, and maybe some tweaks need to be made to the processed water treatment that's used by the industry. Cooling tower chemistry may need to be adjusted. The blow down rate may increase a little bit with the use of the reclamation facility effluent. And then a lot of industries, when they use the water, they are concentrating up the constituents in their feed water through boilers, through cooling towers that, because of the evaporation of the water. So again, it's good to understand the presence of microconstituents and the concentration of regulated constituents, because they may increase in concentration as the industry uses that water, and that may impact their discharge, whether that be directly a direct discharge or whether it's back to the reclamation facility. Some additional considerations for effluent reuse from a reclamation facility are process upsets. So consideration, if the effluent characteristics do change, what impact could that have on the industry's operations, and how do you address that situation? An example might be a change in nutrient removal, for instance. So the industry may see increased concentrations of nitrogen or phosphorus in the water that they're using, and how does that impact their operations and also their wastewater discharge. If the reclamation facility can accept the industry's wastewater back, that's a nice situation because now the industry doesn't have to be concerned about discharging something that maybe they don't add to the water because it was sourced from the reclamation facility in the first place. There's financial considerations, obviously, the capital investment for the pumping and the conveyance facilities, and there may be some additional treatment that's required as well. So who pays for that? And what does the fee structure look like? If the municipality or the community is making the investment, then they're going to want to make sure that they're recouping that investment. So there needs to be some guaranteed revenue, regardless maybe of how much water the industry actually uses. Collaboration and community or communication between the community and the industry is critical. We hear this from this type of contractual arrangement all the time, that ongoing communication is really critical so that the industry understands what's happening at the water reclamation facility and vice versa, and just closely working together to make that a win-win situation. And then public perception it can be a big benefit both for the industry and for the community by reusing water in this way. So industrial water reuse, and by this I mean reuse of an industry's effluent within the facility, can be a good option, again, if there's increased resiliency that's needed in water scarce areas. Sometimes an industry wants to increase their production, but they don't have enough water to do that. And so reuse can be a good option in those situations. A lot of industries already produce very high quality effluent, and it doesn't take a whole lot more to be able to reuse that water within the facility. There can be opportunities for point of use recycle where maybe the wastewater matrix isn't as complex. Maybe there's only a few chemicals that are added at that point of use. And so you can recover the water, and there's actually opportunity to recover the chemicals that are used at that process as well. So that can be a nice option. And then also the stringent wastewater discharge requirements. If there are new requirements coming down the road that are driving an industry to have to treat to a very high quality effluent anyway, just reuse that water instead of discharging and having that having to comply with a discharge permit. So with respect to the point of water use recycling, I mentioned it's a nice option to recover not only the water but chemicals as well. This can apply to a coating process, for instance, where the chemicals can be separated, the chemicals can be returned to the process. For the combined effluent recycling, it's important to understand not only the quantity that's produced, but also the quality. And here again, we need to understand the characteristics beyond what might be monitored for effluent discharge. So a complete ion balance, anions, cations, other constituents that may be present, may not be normally monitored for, but we need to have an understanding of everything that's in that effluent so we can evaluate the impact on the water reuse. And then where can that water best be reused? The quantities and the quality that's required for the reuse points. With that information, then we can start to look at what's the best treatment approach. Do we need to treat for organics? Are we mainly concerned about scaling chemicals like calcium and magnesium? Or are dissolved salts an issue? And it might be one or all of those categories of constituents that would require treatment. So most industries, again, are already treating their wastewater to very high effluent quality. And so a lot of times it doesn't take a whole lot of additional treatment to be able to reuse the water, depending on the reuse that's needed. So for instance, there may need to be some tweaks to the existing process, and then the addition of some improved filtration, like membrane filtration. If total dissolved solids are an issue, then perhaps a technology like reverse osmosis may be required for a part or all of the effluent to be able to remove those salts. Some additional considerations are the concentrated waste stream handling. VJ talked about this, the reject from an RO process. That can actually be, that can represent a very major cost for any reuse project. So that is a consideration. A lot of times the reuse treatment facility capacity does not necessarily, or I should say the daily production rate doesn't necessarily match the water reuse requirements of the industry. So a storage system is required to kind of balance things out. Microbial control for the storage and the distribution system may be required. And then a backup water supply may be required if the reuse facility is down for maintenance or for other reasons. So I have a couple of case studies that I'd like to share with you. The first case study is for water reclamation facility reuse by a power plant. So this was a new power plant, combined cycle natural gas fired power plant that was being installed. The community's water supply was completely tapped out, so that was not an option for water. And so the power plant turned to the community's water reclamation facility as a water source. They needed 4 million gallons per day of effluent to supply water for their cooling towers. And in this case, the community was able to accept the blowdown from the cooling towers back at the water reclamation facility. So that was a nice arrangement. So this required a pumping station at the community's water reclamation facility chlorine contact tank. The water was extracted before dechlorination. There was some supplemental chlorine dosing to maintain a chlorine residual all the way to the power plant. A force main, 3.5 mile force main, a sanitary sewer for discharge of the blowdown water. There were motorized valves provided at the water reclamation facility that allowed remote operation by the power plant so they can control the amount of water that was coming to them for cooling water use. And then they also provided polishing treatment of that effluent at the power plant before they used the water in the cooling towers. And this next example is an example of industrial wastewater effluent recycle. This was a pork processing facility that was expanding its production. They are located in a water scarce area, and there was not a water supply for them to allow that would allow them to expand their production. So they turned to water reuse. So they also had very stringent discharge requirements for nutrients from their wastewater discharge. So they installed a completely new wastewater treatment facility that included screening and dissolved air flotation, a membrane bioreactor to address the nutrients and the organics in that wastewater discharge. They had effluent cooling for the portion of the wastewater that was discharged to surface water. UV disinfection, and then a reverse osmosis process that allowed them to recover 130,000 gallons per day of water that they use in their cooling towers, and they also use it for truck washing. So hopefully VJ and I have demonstrated that there are lots of different approaches to water circularity, and there's certainly not a one-size-fits-all approach. I'd like to have VJ now wrap us up here with just sharing some thoughts on impediments to water reuse.
Thank you, Lucy. As Lucy and I, we start having these discussions about how, as I mentioned, this is very unique that we are talking about community scale and industrial reuse at the same discussion point. However, the impediments, why we are not seeing these reuse projects happening across the board everywhere in the world. So we thought these are the top three. There are several site-specific constraints we can come up with as well. But this is the top three that we came up with. One is the foremost, as we all know, is cost. As whether it's a community or industry, doing a reuse project has a lot of, more than the planning, the capital investment and permitting and others, has a high initial investments comparing to a lot of others. And more than the calculating the cost benefit ROI type of calculation, our recommendation is to look at holistic benefits beyond cost, what it provides for the community as an asset. Is there any collaborative points that we can work with the community, because every gallon or liter we are taking from, let's say, Lucy talks about industrial reuse in its own wastewater, we are avoiding touching the potable water supply. So which is a very big benefit of the community, for the community. So that's then in Reno and other places, I have done triple bottom line analysis that showed having, let's say for a groundwater recharge project, we are importing the water in this area. And by doing groundwater recharge, we are keeping that water in the community rather than putting it in a creek and losing control over that. So there is multiple non-cost factors that has to be considered in order for the reuse project to be successfully implemented beyond, because the initial cost will be higher, and we have seen it in all projects. The next one is the public perception and acceptance. We are just putting both sides of the community and industry together. For example, in the community scale, by now, golf courses and median irrigation, people invite it, public likes it. And especially in the West and Florida, that's become a way of life for us, having the purple pipes in our city. However, when you talk about potable reuse, as a potable reuse practitioner, I can say that working with our outreach team becomes the foremost goal to make sure we are answering the public's question and we are being very open and legitimate. The agency legitimacy is the one in the reuse roadmap effort that we found out that is a key success factor for any potable reuse projects in the community side. And in the industrial side, Lucy and I, we have worked on projects where the industry would like to do an in-product reuse, where you're taking the wastewater, you're treating it, putting it back in the product. That increases the requirement to get public acceptance and also the regulatory acceptance, which we'll talk next. So when you do any type of reuse, the regulatory framework has been evolving. There is no, as we all know, especially for potable reuse, there is no one standard regulation across the board from EPA. However, a lot of states have done a lot of progress over the past 20 years. From California to Florida is in the making, and Nevada has passed the IPR, which is for groundwater recharge, and Arizona is in the process of rulemaking for their DPR, and Colorado was first in the nation to do a DPR regulations. So there's a lot of progress made. Still, if you are a community in a state that doesn't have any regulation, it's a lot of work to get that done first. And also same as industries. If you are in a location where there is no regulations or jurisdiction guidance to apply for it, that takes a little bit more time. And lastly, this is the one practical impediment Lucy and I, we went into, is when Lucy worked for an industry where that's interested and looking to use the water reclamation plant effluent. However, their agreement, there is no standardized agreement that we could send her. So we tried to find 3 or 4 agreements that we could find across the country to see what that works for that particular community and the industry. So that's something where we could work as a team. As an industry, we can develop those kind of framework for a good agreement between these agencies. And I think, Lucy, that's what I think the top 3 is. We can touch more on it if there is any questions regarding this.
Yeah, thanks, BJ. So I think we do have time for some questions. And I believe our host is going to jump in with to help us with that.
Yes, Larica can help. Yep.
Perfect. Thank you both. I have gathered some questions from our attendees. Isaiah asks, are there any reuse projects in the Midwest?
I can take a stab at this. So in terms of reuse projects in the Midwest, there's I've been tracking this for 15 plus years on the reuse side of things. I'm hearing more interest in the recent times than before, I would say. And also stormwater capture and reuse is a lot more of interest to the Midwest communities than the wastewater or industrial reuse, I would say, just from the big picture. However, as I mentioned, there is a lot more interest to do reuse projects from the industrial side and the community side, but it hasn't been to a stage where project yet, I think.
Yeah, and I'll
Interest
just
has
add,
been getting high. Go ahead, Liz.
yeah, just to add that certainly industrial, so water reclamation facility, effluent reuse for industry, that does take place in the Midwest, especially when the main water supply is groundwater and that supply is depleting, and there aren't really good surface water supplies, then that's been a great solution for industry to be able to continue to operate and expand.
Thank you both. Ed asks Lucy, generally, Western U.S. has greater water scarcity than Eastern U.S. Have you worked on water reuse for industries more common to the West versus East? Fertilizer production, mining or tailings, and agri-food?
Yeah, it's interesting because that's how you think of it, that the West is where water is scarce. Obviously it is, and that is a big issue. But the the example project that I gave for the power plant is actually in New England. So water scarcity can, it's different in different regions, but it's everywhere. And so I've worked on projects in the East, New England, in the Midwest, as we were just talking about, as well as the West. And I don't know that it's specific to a particular industry sector either. I think it covers all industries. And in my experience, our clients, regardless of the industry sector, are more and more looking toward water reuse. Again, they're trying to meet their corporate water stewardship goals. And so even if they're not implementing water reuse at the moment, they want to make sure that whatever they do is setting them up so that they can easily implement water reuse in the future. So I think everybody is thinking that way, and that's how industry is moving.
Thank you, Lucy. Sean asks, several examples of RO were mentioned. Are you aware of emerging techniques to recover the RO reject stream for potential use versus discharge or disposal?
Do you want to take that one, VJ, or?
Sure. I think I'll start, Lucy, and I think the economics around reverse osmosis, concentrate management changes with community scale and industrial scale. I think we'll pass it on to Lucy to talk about the industrial side. But from the community scale, we have ran these numbers in numerous times. The even a double-lined pond to put the concentrated reverse osmosis stream, ROC we call it, reverse osmosis concentrate stream, is very expensive. Those leak detection in double liners, that is acres and acres of land is needed to manage that. But if you look at it from the power industry, they do this all the time because I think their way of looking at the cost is different and it's probably needed for them. So that's my big picture answer, that it is very, very problematic one for community scale to deal with those concentrate. And however, I mentioned about ozone biofiltration and other technologies that avoids the use of reverse osmosis. And from big picture, if you're in coastal areas, the practice is to put it in the ocean outfall and dilute it, and which is okay. We had been doing that in several locations around the world. But if you're inland, what you do with the ROC is ZLD, zero liquid discharge, is of interest and is it of practical use, but it is very expensive to do it in the community scale. And there are some emerging technologies that I have seen, but we are waiting for the results to see whether it can be applied in the community side. So.
Yeah, and I'll just
Thank
add,
you.
yeah, we do have one project where we are evaporating the RO reject. It's for a battery manufacturer though, and that concentrate is limited in what it contains, and so we're able to produce salt that is actually sold for beneficial use. So there are those kinds of examples. So it really depends on the characteristics of that concentrate, how complex, and what you're able to recover.
Thank you both. It looks like we may have time for just one more question. Do you know if anyone, WEF, AWWA, et cetera, working on the standardized industry municipal agreement issue at this point?
I am not aware of that.
Lucy,
Yeah,
so
I think
that's
that's a
something.
great, that's a need. That's a need. That
Yeah,
would be wonderful.
I think, Lucy, you guys take it up to the industrial committee, and I'll mention that in the reuse committee, and
Yeah.
we get that started.
Perfect.
So, yeah.
Well, thank you. That's all the time that we have for questions today.
Yes, I just want to thank VJ again for your information that you shared and your passion for this topic. We really appreciate that, VJ. We want to thank our host, AECOM, for sponsoring this webinar. And finally, want to thank all of our attendees. Thank you so much for spending your time with us today to listen to what we had to say. We appreciate it.
Thank you all.